you. The
Process.
yeah, results are important, process are important. Definitely process is important. If you want to see, you have an orange tree and you want to produce apple. When you want to change the fruits, you must change the roots. Without changing the roots, you can't change the fruits. If you try any other method, any other strategy, it will not work. Obviously, you have to work on the root. That means process improvement is the solution to any problem, right? Process improvement is unavoidable. And this is what in Six Sigma we call it y equal to f of x. Y is equal to f of x, where y is the problem we are trying to solve, or otherwise y is the result we want to improve. Y is the gap in performance. Mathematically, y is called dependent variable. Why do I call it dependent variable? Because it depends on several other factors. The moment you understand the problem you are trying to solve is a dependent variable, it is an opportunity for Six Sigma. If it is not a y variable, you can solve it easily. You don't require an approach or strategy like Six Sigma, because Six Sigma is some analysis and then root cause analysis and all that you will be doing to fix a problem. So generally, Six Sigma can be, you can consider applying Six Sigma to solve a problem if it is a problem of y variable. And
So what is f and x?
Yeah, f of x. X are the factors on which y depends. X are the factor on which y depends. For example, your black belt examination score 60 is the pass mark. You want to score 90 and above. Now y variable I told you. Do you think you can change your mark to whatever value you want? Yeah. See, suppose you want to score 90 marks. Tell me, is that score your test mark? Is it a y variable or x variable? Your test mark
X
variable. That means you can fix it wherever you want. Will you be able to make it 90 plus? Will you be able to make it 80 plus just like that? For example, without attending the training, will you be able to score 90 plus?
No.
Then it is not x variable. Then it is y variable. It depends on other factors. It depends on other factors, right? Only when you participate in the training program, maybe go through the materials, take up the model exams, do some assignments, then that guarantees your y. So similarly, in your you are manufacturing a product. Let's say aluminum rods you are manufacturing. You are concerned about the hardness of the aluminum rods you are manufacturing. The hardness of the aluminum rod, do you think it depends on many other factors? Am I right? The material composition, the way you are producing it, are you doing machining? Are you doing heat treatment? What kind of heat treatment you are doing? How do you cool it? There are many things. So everything, finally decides the hardness. You can't fix the hardness the way you want. Only when you handle the factors properly, your y is fixed. So this is how you differentiate y variable and the x variable. If the variable is directly controllable, that is x variable. If the y variable is controllable but not directly, but only through certain other factors or certain other variable, you can control your target variable. That is y variable, right? So when you are trying to solve any problem, what do you see as a problem? Your y is not at the target value. That is your problem. Am I right? Hardness is low. Hardness is high. That is your problem. You want the correct hardness, right? So why your hardness is low? Some of the x variable, maybe the raw material quality is bad, or maybe the heat treatment is not done properly. The heat treatment should be done at 700 degrees Celsius, but by mistake, your people have done the heat treatment at 600 degrees Celsius. That is why the hardness is not at the targeted value. Whenever your x deviates, that will cause a problem. Am I right? Whenever your x is deviating, your y will be a problem. So the X variable, which is deviating from the desired value, those factor becomes the critical factor. Those factors becomes the critical factor. So some of the X factor which deviate a lot, because of which your Y also deviate a lot, those factors are called root causes. Are called root causes, right? So root causes may be 1 or 2. Sometimes no, it can be 3 or 4 also. It depends on the complexity of the problem. When you want to solve a problem, you should be able to identify the X variable which is deviating from the desired level.
Sir,
You need to identify the critical factor. Yes, Sanjay.
yeah, sir. For example, my y variable is depend on some 5 axis, x1 to x5. So, for example, x5 may be y variable if it is depend on other variable also. Correct?
Yes, yes.
X may be also y, but my parent y is different.
Yes, yes, correct. That means a problem is broken down into another problem. A project will lead to sub projects. Clear?
Sir, then what is F?
Yes, great, sir. Great, sir.
What is
F.
F is function of Y is a function of X, right? Y is called a function of X. It depends, that is what we are, we generally mathematically write as saying that a function of. All right. And now the factor which is pulling your Y down is called a critical factor. You must identify the critical factor, nothing but the root cause. And then you must understand the relationship of the critical factor with respect to the Y variable. If the relationship is understood, solution will automatically evolve. Understanding the relationship of the X with the Y is called correlation and regression study. Is called what? Correlation and regression study. If I increase my X, will it increase my Y or not? If the increase in X causes increase in Y, it is called positive correlation. If I increase the X, my Y decreases, that is called negative correlation. So we'll see that with adequate example in the next slide. Sometimes what happens in your company, you may have problem with your existing products. For example, your oranges are not selling properly in the market. Why it is not selling properly in the market? Because it is not, the quality is not up to the mark. Your market is slow market. That means you need to improve the quality of your existing products, and Six Sigma gives a methodology called DMAC. Define, measure, analyze, improve, and control. Use this methodology to improve the quality of your existing products. Suppose if your market is strong, your oranges are going very well, then you can stop improving the quality further, because you already know it is moving very good. The customers are finding it so okay, right? Finding it very good. So now your focus will be producing apples. That means your focus is shifted to new product development. So for that, Six Sigma gives a methodology called DMAT-V. Define, measure, analyze, design, and validate. So if you use DMAT-V methodology to develop new products, that is called design for Six Sigma. That approach is called design for Six Sigma, shortly known as DFSS. Shortly known as DFSS. Now let's understand this strategy better. See, let's